So this last video in my series on differentiation is going to be looking at the more difficult type of function. So you might have something that looks like this, y equals x squared over x to the 5. And your key here is to express your function in the form of where you have x to raised to a single power. So in this case, you're going to be applying your index laws. So x squared over x to the 5, or x squared divided by x to the 5, you know that's the same as y equals x to the minus 3, okay? So when you have division, x squared divided by x to the 5, you subtract your power. So subtracting 5 from 2 will give you your minus 3. Okay, now this is in the form where you're happy differentiating it, okay? Because you've expressed it as a single power on x. Simply bringing your power to the front will give you minus 3. X, decreasing that power by 1 gives you minus 4. So that's the first example. Second example, y equals x times by x to the 4. Again, applying your index laws, you need to express this as a single power on x to begin with. X times by x to the 4 gives me x to the 5. So when you're multiplying things with the same base, you simply add your powers. Remember, my power on x there is essentially 1. 1 plus 4 gives me my 5 up there. And again, that's in the form you can differentiate now. dy by dx equals, bring my power to the front, decrease my power by 1, leaves me with that. A slightly more difficult example now. If I have this, y equals 1 over x to the 4. Again, you need to express this. I'm just going to go over here, otherwise I'm going to run out of room. Express this as a single power on x. You know, 1 over means that you're going to have a negative power. What's my negative power going to be? Well, it's going to be 4. Okay, so if you just take a look up here, using your rules, if I have, say, x to the minus 2, you know that's the same as 1 over. So x to the 2. Similarly, if I had x to the power of minus a third, again, it's going to be 1 over. X goes there. Your power, whatever that is going to go there. So differentiating this, express this as a function where I have x raised to a single power. Bring my power to the front, decrease my power by 1, gives me minus 4x to the power of minus 5. So just running you through a few more examples now to finish off with. If I have this, y equals 1 over the square root of x, again, you need to express this in a form such that I just have a single power on my x. So notice here I have 1 over, so presumably the answer is going to be x raised to the power of minus something. Now, if you look at this denominator here, what's the power on my x in this case? Well, it's square rooted, so the power of my x is actually going to be a half there, or minus a half here if I've got 1 over that. Okay, so that's y equals x to minus a half. Similarly, if I had cubed root here, it'd be minus 1 over 3 here. If I had, say this, okay, just applying your index laws there. On the bottom there, I would have x to the power of that's the wrong way around. I'd have x to the power of 2 over 3. So that 3 is a number there. So it's the kind of order of the root that you're looking at. And then the number outside the brackets there is the numerator of the fraction. So just applying your basic index laws. Obviously, I do have an entire video looking at this. But because you have 1 over there, you have a minus. Okay, so again, just applying your index laws to express your function as a single power on x, and applying that, bring your power to the front, applying your laws of differentiation, and then decrease your power by 1, so half minus 1 equals minus 3 over 2. Now this one here, if I have y equals 1 over 5x cubed. So if you notice how this differs from this and the other examples that we looked at, so we looked at something like this previously, y equals 1 over x to the 4, or y equals 1 over root x. Then you notice there is no number in front of my x. There's no coefficient on my x on the numerator of that fraction. When this is the case, first step, you want to get rid of that denominator, so that coefficient in front of my x there. How do I do that? Well, I'm just going to rewrite this as 1 over 5 times by 1 over x cubed. So just to verify that this is indeed the same as this here. Well, if I multiply, remember when you're multiplying fractions, you multiply the top by the top to give me the top. So in this case, 1 times by 1 does equal 1. And the bottom, 5 times by x cubed, it does give me 5x cubed. Okay, now that I've done that, I can express the second bit here. It's 1 over x cubed as a single power on x. So that's x to the minus 3. And now I can differentiate that. That's in the form where I can just apply my rules. Okay, so bringing my power to the front, I've got minus 3. I need to combine it with this 1 over 5. That is essentially my coefficient on x here, on x and minus 3 there. So combining this with this, bring my power to the front, I have minus 3 over 5. And then x to the minus 3, decreasing that power by 1, I get x to the minus 4. Okay, so 2 steps. When you have a coefficient on the denominator of your fraction, so a coefficient on, in this case, x cubed, but it could be x squared, it could be any power on x here, you need to split this fraction up such that you remove that coefficient. So if this was a 4 in front of my x cubed here, then the fraction that I would be taking out here would be 1 over 4. If this was 7, it would be 1 over 7 here. And then once you've done that, should be in the form such that you can express this second fraction here as a single power on x, and once you've done that, you can apply your laws of differentiation. A few more examples that we need to get through. This one here, x squared times by x minus 7. Okay, again, the trick with these questions is trying to get your terms expressed as a single power on x. How are we going to do this in this case? Well, you notice anything in this form, it's fairly safe to assume that you're going to expand the brackets. So let's do that. X squared times by x gives me x cubed. X squared times by minus 7 gives me minus 7x squared. And then that, each of those terms are differentiable. You know how to differentiate those. You're just going to apply your laws. So here, bring my power down to the front, decrease my power by 1. Here, similarly, that's minus 7 now becomes a minus 14. If I bring that power to the front, that 2, decrease my 2 by 1, which gives me x to the power 1. Here, don't need to write that 1 up there. That is my final answer. So if you're presented with something that looks like this, you need to expand the brackets. Now these ones here, the way we get this into differentiable form is that you split up this fraction into 2 fractions. So if I have something like this, I can split it up into 4x squared over x to the 4 minus 5 over x to the 4. So essentially splitting up the top of that fraction, and then the denominator is your denominator there. So just note that I can do that, but I cannot do this. So x to the 4 over 4x squared minus 5x, that is not the same as x to the 4 over 4x squared minus x to the 4 over 5x. So I can split up the numerator, but I cannot split up the denominator like this. In other words, if there's a single, there are two terms on the top and one term on the bottom, then I can split it up. Whereas if it's flipped over and I have one term on the bottom, one term on the top and two terms on the bottom, then I cannot split it up in the same way. And now this isn't in differentiable form yet. Remember, you need to express these as a single power on x. So you can work on each of these. 4x squared over x to the 4. Well, what can you do there? You can cancel this. There, so I'd have 4 over x squared minus, do the same here, 5 over x cubed. And you can express each of these as a single power on x. So here, remember 1 over x squared equals x to the minus 2. So if I've now got 4 over x squared, or 4 lots of 1 over x squared, that's just the same as this. And then similarly, applying that same rule there, I have that. So my dy by dx, applying my laws of differentiation to this expression here. Okay, remember, we need to get this in the form such that your x just has a single power on it, which we have there. So looking at this first one, minus 2 times by 4 gives me minus 8. X, decreasing that power by 1 gives me minus 3. Similarly, looking at this one, minus 3 times by minus 5 gives me positive 15. X, decreasing that power by 1 to the minus 4 there. Going to take a look at one more example now. Remember, this is all in hard form in my notes on my website. Y equals x plus 6 over x cubed. So this looks like the example we had previously. So we're going to split up this fraction like that. So just separating my numerator out essentially, and then keeping the same denominator. Okay, how can I rewrite this such that I just have a single power on my x? Well, if I cancel that, that will decrease down to 2. So I have 1 over x squared plus 6 over x cubed, which is the same as x to the power of minus 2 plus 6 lots of x to the power of minus 3. I'm working through, differentiating this one, so moving my power down, decreasing my power by 1. And this one becomes a negative, minus 3 times by 6 gives me minus 18, x decreasing my power by 1, x to the minus 4. So just to summarise, I looked at a few different examples here. Something like this, okay, you should look at that straight away and think, I need to expand the brackets there. You've been doing this since year 8, year 9, when you have one term outside the brackets, two terms inside a set of brackets. You know to expand those more often than not. Here, this is new, so splitting up a fraction, you can split up the numerator if you have two terms on the top, separating them out like that. That was exactly the same as this example here. So really the key to each of these questions is expressing your functions in the form where you just have a single power on your x. You know that in order to differentiate, they need to be in that form, and then you're just going to apply your laws of differentiation to get to your final answer, your first derivative. Thanks very much for watching, and don't forget to subscribe for more tutoring videos. Remember that full notes and other resources are available on my tutoring website at idktuition.com. And if you'd like me to cover anything in particular, please leave me a message in the comments below or on Twitter at TomDavies32.